Okay, here we are for our next video that deals with the moon, and we've been talking about moon phases, and today we're going to talk about the moon tide, how the moon causes the ocean tides to occur. Okay, so in order to understand a lot of this, you do need to maybe review what we know about the moon and its revolution around Earth. So far what you guys have predicted for us in class is the idea that the moon, which we'll put right here, and there's Earth. And because both objects have mass, they both have gravity. And the idea here is that the moon has a gravitational pull on Earth, which doesn't move Earth very easily, but because the water that surrounds Earth is not connected to Earth, the moon's gravity can much more easily pull on that water. That's what you guys gave me in the beginning. Absolutely correct. As you talked about it, you guys said that there was a second high tide on the opposite side of Earth, but weren't too sure of what was going to cause that high tide. Well, as we discussed a little bit more in class, what we talked about was the fact that, yes, indeed, the moon does pull on the water, but the moon also pulls on Earth, but can't pull on the water on this side of Earth. So as Earth is pulled towards the moon, the water on the opposite side of Earth is left behind. Now at the same time as that, we also brought in this idea of inertia. And if we can go back to Newton's laws of motion, inertia is the resistance of an object to a change in its motion. Earth is rotating, which means that the water on Earth is rotating, but objects would like to continue to travel in a straight line. The water wants to travel in a straight line as it goes around this side of Earth, but Earth's gravitational pull doesn't let the water escape. Put that together with the idea that Earth is moving towards the moon, the water's being left behind, the water's trying to escape, and now we have a high tide bulge on the moon side where there's gravity, and on the opposite side where again Earth is being pulled towards the moon and the water is trying to escape. Now from these ideas that you guys had come up with, you made some predictions. And you looked at Earth, you looked at the tides, and it made sense that the tides should be about 12 hours apart from one another. The high tides should be about 12 hours apart from one another. Meaning if we had a high tide on this side at 12 o'clock p.m., then we should be having a high tide over here at 12 a.m. Now when you look at Earth and you cut Earth into quarters based on that, well then that gives us the idea that the low tides should be about 6 hours before or after the high tides. So that would give us a low tide over here at 6 p.m. and a high tide, another low tide over here at 6 a.m. Okay? Now, we throw in some other ideas here. The fact that the moon is revolving around Earth while Earth is rotating. All right. Okay. So, let's draw this a little bit differently, like we did in class. So we're going to put the moon at a position right there. We'll put Earth at a position right here. And we're going to put you at that high tide position. Okay? High tide, low tide, high tide, low tide. Now, Earth is rotating. The moon is revolving. So I posed the question in class, how far will the moon move in its revolution across one Earth rotation? The answer ended up being that the moon will move 1/29th, or approximately 1/29th. And the reasoning for that is that it takes the moon 29.5 days to revolve around Earth. So if Earth rotates once, the moon has moved 1/29th, or approximately 1/29th, of its distance in its revolution. Okay? So now if we go a little while later, back to that 6-hour idea that you guys had originally come up with, well, within 6 hours, the moon will have moved in its position. Instead of being here at that straight up position, it's actually going to be a little bit to the side of that position. Over those 6 hours, you would have moved to here, but you still wouldn't quite be at a low tide, so we have to move you just a little bit further to get to that low tide. So now if I put in the tides, we can see that the high tide has moved a little bit to the side. Okay? Again, Earth continues to rotate while the moon continues to revolve. And if we keep doing this, we're going to see that every time we move your position on Earth, we actually go a little bit more than that 6 hours that you guys had originally suggested. The moon was here, then it was here. Now I'm going to draw it just a little bit further off to the side. Okay? And the tide keeps shifting a little bit. And it will continue to shift until we get back to what should have been a full rotation for us. But if we look at the tide, we can see that that high tide is no longer where it was yesterday. So we actually have to move to that spot right there, which in the end ended up being 25 hours. Alright, so let's look at an ocean tide chart. Alright, what we started doing was we started playing with the numbers a little bit. And we looked from one tide to the next tide. And if we go from 3:03 to 9:32, that's going to be 6 hours. And if we count forward from 3 minutes to 32 minutes, that's going to be 6 hours and 29 minutes to go from one tide to the next. And then, if we go from that low tide at 9:32 to the next high tide at 3:36, we're going to end up with 6 hours and 4 minutes. And if we jump again to the next tide, we're going to be at 6 hours, 10 minutes. And if we keep doing this and we keep making our jumps are going to be a consistent 6 hours, but you're going to see that the minutes will change. Now in class, when we averaged out some numbers, we came up with 6 hours and 11 minutes. Told you that the reality is more like 6 hours and 13 minutes. So to keep things simple so that we can make easier predictions, because we're only going to be making predictions for 1 or 2 days into the future, we're going to keep our tide shifting at approximately 6 hours and 15 minutes. Now over just a couple days we can do that because it's only going to play with the times a little bit. If we were making actual tide charts, we would have to do something a little bit more intricate than that. Now while we did this, we also said, well, let's see what it is from one high tide to the next high tide. And on that one, you can see that it takes 12 hours and 33 minutes. And from 3:36 to the next high tide at 3:58, you can see that that's going to take 12 hours and 22 minutes. Okay? If we look at the low tides, and we do this same thing, we can see that that low tide right there is going to take us 12 hours and 14 minutes from low to low. And then if we went to the next low tide, we can see that it's quite a bit different this time. Okay? This time we're still under 13 hours, but we're at 12 hours. 46 to 10 o'clock is 14 minutes. 14 minutes plus the 32 minutes right there is 12 hours, 46 minutes. Okay? So again, we play with the numbers a little bit, and we decided that simple number to work with, that works with these numbers, works with doubling our 6 hours and 15 minutes, would be to say approximately 12 and a half hours or 12 hours and 30 minutes. So now if we were going to make some predictions on this tide chart down here, okay, we're on Sunday the 23rd, we have 4 tides. We know that we're never going to have more than 4 tides in a day. We did say that depending, we could only have 3 tides in a day. We're going to end up going to Monday the 24th. I'm going to do this slowly because I want you guys working along, okay? And we have a low tide at 11:52 p.m. What time will the next tide be, and what will it be? Okay, well, if you did your math and you added 6 hours and 15 minutes to that, you should have come up with 6:07 a.m. Why don't you pause the tape for a second and calculate the next 3 tides for this day. You know, when you got to this point, did you realize something? If we add another 6 hours and 15 minutes to this, we're going to end up, at 12:52. But that's going to be a.m., so that's actually on the next day, March 25th. Now, if you give that some thought, it's only going to make sense, because we talked about this. It takes the moon 25 hours, or excuse me, it takes Earth 25 hours to rotate back to the position where your spot is going to be under the moon. 25 hours is more than a day. It's going to cause the tides to sometimes only have 3 in one particular day. Now, the part that I didn't clarify here a little bit earlier, but hopefully you can see in this illustration, is that one of the things that we learned was that the high tide didn't actually happen right under the moon. The high tide was actually a little bit above that moon. Now, we had talked about that when we first started this by finding lunar noon and saying, well, that's when the moon is overhead, that's when it's going to have its greatest pull on Earth. But that tide is going to be a little bit ahead of the moon because of the way gravity works. Sorry about that. I thought that the tape was paused. So now we're going to get to the last two phases, the neap tides and the spring tides. All right? And this deals with the relative position of the sun, the moon, and Earth. Okay, so let me just go ahead and put up two quick pictures. We're going to put the sun here. I'll do a second sun here. Let me put the Earth here, straight line with the sun. Okay, and then I'm going to do two different ideas. I'm going to put the moon in a straight line, so that's going to put the moon at either a new moon or a full moon. Or I'm going to put the moon at a right angle, which is going to put it at either of the quarter moon positions. Now, one thing that a lot of people had asked was, what about the sun's gravitational pull? Does that have an effect? Well, the sun does have a gravitational pull, but because of the distance, the sun's gravitational pull on the water isn't as strong as the moon's gravitational pull on the water. So let's draw in some tides here based on the moon. Okay, and we're going to have a high tide there. We're going to have a high tide there. Now, if you think about it, in this one it really doesn't matter which position the moon happens to be in, because if the moon is right here, we have high tide right there, and on the opposite side we have our high tide because the moon is pulling on Earth, the water is left behind, inertia brings the water out. If the moon is right here, we have the same idea. But now, let's look at what's happening. Now, in this illustration, the sun is also pulling on the water. So that sun pulling on the water, in addition to the moon pulling on the water, is going to make this high tide even higher than it normally would be. Now, these tides that are higher than they normally would be are known as spring tides. And again, if you look at the picture, the only two phases that a spring tide can occur during is a new moon and a full moon. We have the gravitational pull of the sun and the moon cooperating with one another, causing those tides to be just a little bit higher. Now, if we go to this diagram over here, and in case you need it, let me just draw it out for you. I said that we're talking about a right angle. Okay? So we're talking about the sun being in a straight line with Earth, but then the moon being at a right angle to that. Now we know the moon is still going to pull on the oceans and on Earth because of gravity. So when we're in this position, we're going to have our tides. But we also know that the sun has a little bit of an effect right there. So this time when we draw our high tides, they're not going to be as exaggerated. Excuse me. They're not going to be as exaggerated as they were in the other positions. And if you compare the distance that I've drawn here with the distance that I've drawn here, you can see there's quite a difference. Okay? This tide is known as a neap tide. And that's when we have the lowest high tides. And if we look at the position of the moon in these being at that right angle, we're talking about our first quarter and our last or third quarter moon phases. Nothing has changed in this diagram as far as the cause of the tides. It's just that now we have the gravitational pull of the moon and the sun working at right angles. I hope that all of this has helped you out. Make sure, once again, to study. Come to me during ATT if you have questions. And let's do well.